Hello, welcome to CocoaHeads 193. Great, thanks everyone. In the spirit of reconciliation, Melbourne CocoaHeads acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Okay, we have some awesome talks tonight. April and Nabila from Girls at Geek Academy. Can I say? Yep, great. Will be telling us about sort of they're here to support International Women's Day, as we all should be, and to talk about She Hacks Swift. I'll let you explain it because I don't want to mix it up. Okay, and Luke Howard as well, an embedded audio product built with Swift. Okay, awesome. We've got a code of conduct here at CocoaHeads. We want people to feel safe and included, so if that isn't happening, let either myself or Bok know, and we'll do our best to fix it. There's also a anonymous, there is a form online at that URL, maybe. Is that right? Yep, great. Fix that if it's not there. Cool. It's an online, like we stream these talks as well, these nights. So if you've got any questions, we typically wait till after the talk's done and we pass microphones around so people online can also ask questions. But if the presenter asks directly a question to you, you're allowed to answer. Yeah, if you're online, go to Melbourne, or go to the Slack channel Melbourne Meetup and ask your questions there. Great. Thank you to our sponsors, Mantle Group. We couldn't do it without you. And REA Group as well. Oh, Andy's, come up. This is you're about to come up. So we've got a special guest here today as well. Can I just hold this for you?
I'll just speak into this.
I'll just duck down.
Hey, it's been a while since I've been up here. My name's Andy. So I just want you're freaking out.
Yeah, no, I gotta stand.
Yeah.
I'll give this to you.
So yeah, I just want a quick shout out to this conference that's happening in Berlin on the 7th, from the 7th to the 9th of October this year. Why am I talking about this? Mainly because I'm on the talks committee, so I'll be reviewing talks to select some presenters to present at next app conference. And from what I understand, chosen applicants or speakers will get accommodation and flights provided for them, so that's always a really good reason. The CFP opens up, from my understanding, sometime next week, I think. So definitely, if you have a cool talk, we'd love to hear from you, and I'll be there, so it's going to be really, really good. But also, a bit of context about this. So NextAppCon, this is their first one for the Swift language, but they are actually DroidCon expanding. Like the organizers of DroidCon worldwide, they're expanding to be pretty much the biggest app conference in the world for mobile development and AI and AR, XR and all that kind of stuff. So it's going to be really good. Hopefully you can get some CFPs in if you have some really good talk ideas, and just reach out to me or hit me up during the breaks, and if you want to have a chat about it. Thank you very much.
Thank you, Andy. Thanks, buddy. Some other events on this month. Coding night next Wednesday. We do that with Google GDG and Flutter. Just sort of people bring their laptop. It's an alcohol-free event, so it's family-friendly, just to code and work on your projects. There is also the CocoaHeads Social Night on Tuesday, 31st of March at Brick Lane Brewery. Second floor, brewing. Okay, great. Another event, you've got something to say quickly? Okay. The other event on this month is Jane's birthday. So let's all put our hands in, yeah. And we're gonna sing a little happy birthday. And Marcelo, to start off in C, maybe. Happy birthday to you. Happy birthday to you. Happy birthday, dear Jane. Happy birthday to you. We did it that time. That's it, everyone. Okay, great. Cool. Do you want to say anything before we move on? No.
I demand my real
Okay. Good. All right, that was fun. All right, some other groups that support us and we support. There's Sydney CocoaHeads, GDG Melbourne, and down the bottom is all the other CocoaHeads around Australia and New Zealand. So if you scan that QR code, you can see what other events are on this month and for the year. To find us, you can go to melbournecocoaheads.com and jump on our Slack as well to the Melbourne Meetup for tonight. And the Slack channel is all of Australia and New Zealand. So there's plenty of stuff to keep you entertained. Great. On Slack, you can jump on the volunteers channel, which I'm always preaching to jump on and join us. You can get up here and do this. It's not as hard as it looks. Then there's the hashtag jobs channel. If you're looking for people or, looking to get someone to hire you, you can jump on jobs. And if you want to speak, go to speakers, hashtag speakers. Or if you want speakers to talk about something, put a suggestion there. I think that's a good idea. Give someone an idea to maybe they talk about. Show demand. All right. I've done my portion of the evening. We're going to pass it over to April and Nabila, if that's fine. Thank you. Give a round of applause to April and Nabila. Okay, awesome.
Okay, now everyone can see the slides. Hi everyone, I'm Nabila and this is April and we are from Girl Geek Academy. Today we'll be presenting about, in the spirit of like International Women's Day, we'll be presenting about She Hacked Swift. It was like a workshop organized by Girl Geek Academy in partnership with Apple, where we actually run few days of workshop for high school students during school holiday, hosted in Sydney and also Melbourne. When we help them to actually create their first app for iPad and also iOS for the first time. And we also try to encourage them to actually submit like a Swift Student Challenge as well. So an introduction about ourselves. So I'm Nabila, and I think some of you may be already familiar with me. I'm currently a senior iOS engineer in SIG, but previously I've worked in Mental Group as well, and April.
And I am not an iOS developer, although I did moonlight as one when we ran this event, which was interesting because I learned a lot about Swift, which was entertaining, or Xcode, I should say. I work for NAB, so I do all sorts of crazy shit there, and we'll leave it at that.
Yeah, and I don't think a lot of people are familiar with what is Girl Geek Academy, so maybe I'll let April to
Okay,
introduce.
so look, we've got a whole bunch of slides, and I'm just going to go through a little bit of an origin story before I go into these slides, because it can give you a bit of context. As you know, context is everything. Originally, Girl Geek Academy actually formed out of something called Girl Geek Dinners. Back in 2014, we ran what became the world's first all-female hackathon. And we actually just ran it as a thing that we thought was going to be fun. So there was a whole bunch of us, and we decided, hey, well, it was through the meetup groups, well, we're going to run a hackathon. And we called it She Hacks. And the turnout was incredible. We hadn't really kind of seen how many women were in tech, and we're really interested in having a meetup that was a little bit different. Now, I'm not sure if the same enthusiasm's happening around meetup anymore, but it certainly started this way, and we decided basically to form Girl Geek Academy. One of the main drivers, and this is kind of like some of the stats, and we've got a few of these slides, and I'm just going to go through them. It's really about, improving. We want to get the most out of tech. Having women involved is going to help, right? And some of the things that we need to try and fix are things like, the number of women that are in STEM subjects, the percentages of engineers, and then the percentages of engineers that end up being in higher positions such as, venture capital, CEOs and so forth. And this isn't particularly great. There's some sort of couple of findings around, the got to remember, I'm the engineer, right? So the hustler is not here. We basically have done a whole lot of research over the years, and some of the things that we've found really is that there's a lot of misnomers about ways that we can try and fix the problem, and actually try and encourage more women in tech. And they're things that a lot of women who work in tech have probably experienced. I've started back in the 90s, so I've experienced all sorts of crazy stuff. And it's about fixing, the paths, not necessarily changing the girls to suit the problem, but, maybe we need to fix the problem, because the problem isn't just limited to girls. And we kind of look at, and this is actually fairly true, and I want to sort of summarize it without making it kind of like a political statement, but women do get pushed out of tech. And I've seen it, and I certainly had seen it in the early days, and was probably worse. It's probably not as bad now, particularly in where I work in corporate, but I'm sure it's not like that everywhere else. Where there are lots of little things that basically contribute to you not actually wanting or ending up in a career in technology. And that's a shame, right? We've got all this investment in people, in educating, and not necessarily reaching their full potential. So it's kind of like a death by 1,000 little cuts. So what we really identified, that we've got a bit of a pipeline problem. And it starts off very young. It starts off at primary school, where kids, they're all the same. They all kind of have their ambitions. They don't really care. They're free thinking. When you were a real little kid, you wanted to be an astronaut, right? That certainly was never going to happen. But the sky's the limit. And as you progress through high school, university, and so on, and then in industry, you're kind of funneled into things. Now your friends help you with that, and but you're also influenced by external factors. A lot of young girls make the decision of whether to go and do the right sort of subjects that ends up in whether they're able to get into university and do a technology degree quite early. And they're kind of influenced that way. So we want to try and at least expose children and expose teenagers in particular when they're making those decisions to what it means to work in tech. Like, it's not as dire, it's not sitting in a basement hacking, unless you really want to do that. That is, there are a lot of other opportunities to work, to have a family, to be able to collaborate and do all those things that you want to do and still be successful and still contribute. And then coming back to the first slide, to contribute to the greater good. So it's all those little things that get women inspired. It's a lot of things like role models and actually having examples of women working together in the hackathon type style, which is really what we did with She Hacks Swift. So that's really about talking about solutions. Now, we ran a hackathon in 2014 that kind of changed us and got a lot of, look, we're essentially all younger engineers. I was younger too. And it was just a lot of fun because we, cranking up with all sorts of stuff. This is back when there was still iPhone 3s around. And that model of inspiring younger girls is something that we're doing with these hackathon style, but we're doing it obviously for a much younger audience and actually teaching them practical skills. I was a little bit afraid when I started this because I actually thought Xcode was a little bit hard.
Still hard.
But actually, I was surprised how well they adapted to it. Just shows you agile young minds can adapt to even the worst user interface. Did I say that out? So what we know that works is women-led solutions and investment in women-led organizations, entrepreneurs and businesses. And then setting gender targets within organizations also helps, so we don't have that death by 1,000 cuts. Let me just skip through this because I don't want to keep on talking about this forever. So we already kind of touched on that. This is a really kind of key message, is what would the internet look like if there were more women building it, right? And people always have the perception about what that means. Is it going to just be lots of pink things? And probably not, right? It's all about collaboration and all the other attributes that are typically associated with women. It's a really good question. Is it going to be different? Is it? Will it just be the same? Is there an assumption that it would be the same? Is there an assumption that we're all just actually going to produce exactly the same thing? I don't know. I think this is a very good question, and it's something that I think you need to think about. Imagine. And would it be better, right? Having that kind of diversity, I think diversity is always better. Diversity of thought is how we innovate, right? So I think it gives you those opportunities. Otherwise, you stagnate. Okay, She Hacks Swift. Yep. So we did two. There was one in Sydney and one in Melbourne. We tried to follow the hackathon kind of mantra. Now, the logo that you see in the corner there with the keyboard, that's the same logo we used, apart from the She Hacks Swift at the bottom, when we did the first event in 2014. And we've run quite a few since. So, do you want to take over from here?
Yeah, I also want to add that this program is actually in partnership with Apple. And this is also the second year we run this event. We actually ran this event in 2025 as well. The program is free, so any high school students can apply and they're not being charged in anything. And even if they don't have any MacBook or iPad or any Apple platform to build their apps, Apple actually lent some of the devices on the day. So I'm going to show you some pictures or photos of the participants. It looks like it's staged, but yeah, this was actually, I think the photos for media, for the news and press. Oh, I don't know why that's blank. Yeah, and some of them actually showcasing the apps that they made. You've seen a familiar face as well. Oliver was volunteering for the day, I think, for Sydney and Melbourne once. So in terms of like technical stack, and if you're curious, like how do they write or build the app? As you know, Xcode is very difficult to use to some people, and some of these participants, they may not have like any programming background in the past, or even prior to these workshops. So we actually use app playgrounds. It's the one that you can run on iPad, so it's not Xcode Playground, but actually I saw that there was a handful of students in a Melbourne workshop that was actually using Xcode. And most of them are building it in Swift UI because it's very easy to learn, because it's declarative. But there was like one particular student who was building their app in UI Kit. And I was very surprised of that, of her decision. And I asked her about it. Why do you choose to build in UI Kit? And do you have like any prior programming experience before? Do you understand like how difficult it is to build app in UI Kit? She's aware of that. She's aware that it's much more difficult to build an app or even like a simple view in UI Kit. But her reasonings, because according to her own research, a lot of companies in Australia are still building app with UI Kit, and she was afraid that if she only learns about Swift UI, she may not be employable in the future. So, well, I told her that hopefully by the time she, finish high school, graduate uni, everything will be in Swift UI. But like, I guess this is like some reminder for you all. Some of these students, these younger generations, they're only exposed to Swift UI, not even like Objective-C. So perhaps try to get like your project to migrate to Swift UI as soon as possible.
Now it was, and you've got to. So this is a competition that's coming up, right? So they're like 15 years old, and they're doing this. Now I need to actually correct you, because in Melbourne that may have been the case, but in Sydney we couldn't get playgrounds to work because Apple had pushed an update, and this is the so-called glass effect, which we all love, and it broke it. So playgrounds wouldn't work. So we had a room full of students, 15-year-olds and thereabouts, so that age kind of range. And yes, we went straight to Xcode. It was great. What impressed me was it wasn't a problem. And they were able to pick it up. And I think for some it was the first programming language that ever used. So it was quite impressive.
Yeah. So given that some of them don't have any prior programming experience, actually the first few days of the workshop, some of the tech mentors actually give like some tutorials or like resources where they can actually self-study. Like how Apple officially released some tutorials like how to build an app in Swift UI, how to build certain views like navigation view to detail view and stuff like that. And it's actually very surprising like how quick they can learn just within a day, just by quickly learning a tutorial within an hour, and the next hour they can start experimenting, building an app on their own without much assistance. But obviously they still encountered like some technical issues, and the challenging thing developing using App Playground is when there's an error, even like a syntax error, it's not really giving like descriptive error message. So sometimes I actually had to help them to open their project or their app in Xcode to actually figure out what is wrong. What else? Yeah, a lot of them actually have a lot of refreshing ideas. I think common themes that I encountered during the workshop is an app about like taking care of your mental health, such as an app that can actually generate like a bunch of words of affirmations, an app that can help student to study, like have a study plan. And it's an app that educates them about like reproductive health. So, well, I guess this is like one of the great advantage. If there are more women in tech industry, we can actually build a product that is much more catered to women, because what do men know about reproductive health? Yeah. Okay. So the woman in the center of the photo, that's Fiona. She actually flew from Indonesia. She works at Apple Developer Academy in Jakarta, and she actually helped mentoring these students for both workshops, Sydney and Melbourne. Yeah, I just find it like it's cool. Like she flew all the way across the globe to help the students and inspire them too. Yeah. Oh, that's Sarah. And yeah, looks like they just fixed a bug. I mean, look, the kid was looking very ecstatic. Yeah, and if anyone is interested, we can always send an email to this email address above. Is there any way they can like reach out? Do you know, like to if they want to volunteer for Girl Geek Academy? Do you know?
Hello.
Yeah. So yeah, basically just
They just through the website is probably the easiest. But also, I mean, you probably know some of the individuals as well. You can always contact them. So
yeah, or even like contact me, and I can probably pass your contact to Sarah. Or
I think Oliver is famous here, is he? Or
yeah, yeah, you can also contact Oliver. And yeah, unfortunately, Fiona can't be here physically because she's based in Indonesia, and virtually as well. But we have a video of her talking about her experience mentoring these students in She Hacks Swift. Okay, hopefully the audio will work. Oh, sorry, let me just like open this. Okay, enlarge and oh. Okay. Do let me know when. Okay, let me press play. Oh. Try again. Like this?
Hi, my name is Fiona, and I'm a tech mentor at
Sorry, another technical difficulties. Ah, gotcha. It's just.
Hi, my name is Fiona, and I'm a tech mentor at Apple Developer Academy at UC Jakarta. And I've also been a mentor with She Hacks Swift for the past 2 years in Melbourne. And being with She Hacks Swift, it's been an amazing experience because everyone is so full of energy and determinations. And they're very creative as well. And the girls are actually very hacky. I initially thought that they will need a full lecture on basic Swift, but turns out all they need is a good resources and also good tutorials. And they will just follow along the tutorials to make their own app. And some of the girls come up with an app about self-affirmations, and some of them come up with an app about the environment and also about thrifting. Those are amazing, right? And the most rewarding moments for me was when initially they were struggling, but then they kind of make it in the end. And they are so proud of themselves for it. And that's the best part of being a mentor. And yeah, program like this should be continue, the space where they can create something, they can build something. So I cannot wait for the next She Hacks Swift. See ya!
Yes. So another thing I want to show is basically, I think it's this one. Oh, no, it's 2025, sorry. It should be this one. Yeah, I don't know if I have much time to actually showcase all of these apps, but oh, look how cute they are. Yeah, these girls, they have so much ideas, and some of these ideas actually require using, APIs like foundation models and also MapView, and that's when mentors like me stepping in, helping them like how can I set up for them? Or usually I just give them like resources, the tutorial where they can follow, and then they can just do it themselves. So this is the second year I volunteered for this She Hacks Swift event. One thing that I want to highlight is I actually saw some familiar faces on the second year of this event. Turns out some of them actually attended the workshop last year as well, and they also recognized me. And these girls are actually entering their final year in high school, which is year 12. And some of them actually are interested to pursue, a career as a software engineers or mobile devs, and they ask me questions like uni choices, or even like asking, day to day as a software engineers, do I have to write a lot of code? Well, I tell them, not really, because most of my time spent nowadays is on meetings. And I also told them about like what is the code review process. You can't just write your code and publish it. You still have to get like some review and approvals. I think they asked me these questions because they see someone who like themselves in the industry. So this is when representation really matters and actually showing up. And I'm happy that I can actually participate in and volunteering on events like this, like She Hacks Swift, to be able to inspire young girls and hopefully give them confidence and believe that they can also be in tech industry. They can also be an engineer, despite like, an engineer in IT industry has the stereotypical of like male and nerdy. No, they don't have to be a male and nerdy. They can just be, a girl likes girly things and likes to build the girly things as well. Like, look at this, cute stuff. And I wouldn't be surprised if perhaps in 5 or 6 years' time, I will see them again, but not as a student, but as an employee in SEEK, doing graduate program.
Very likely. So, we change, and we do change through doing little things like this. There'll be other, events that are not necessarily all Apple focused, but it's just something we do. And look, one of the things that I kind of got out of this was I remember the joy of programming when I first learned to program, and that being able to take someone else's code and hack it. Except mine came from the back of a Commodore 64 manual, which shows my age. But it wasn't really, too different. Well, a whole lot of memory more. But it was just really good to see that creative, inspiration using existing knowledge and then enhancing it for your own benefit, which is really the model they followed, and some of the examples in Xcode, the tutorials are actually really good. So that is kind of, I think, how most of them learn. And obviously we were there to try and get them out of, problems like, where did all the images go? Which is always a mystery. But yeah, it was the creativity is the thing that I really loved, and just a whole lot of fun. And I think that was the good thing. It's like, the kids go out and they go, that was a lot of fun,
Yeah, some of them I think are interested to come again next year if we are hosting it again. And even during the workshop, even though almost every student have their own project, but they were willing to actually collaborate between each others, like solving like some bug issues together, or even developing ideas together. So it's just really wholesome to actually see it, because I think sometimes adults, they're not really as like collaborative as like young kids like that.
Yeah. Okay.
Actually, another thing to add, Apple tried to encourage these girls to actually submit their project into Swift Student Challenge. I think some of them have submitted, but I just don't know which project that was being submitted. I think that's all for me.
Questions, yeah. But
If there are any questions.
Can we clap first?
Oh, yeah, everyone can clap.
Awesome. Okay, questions around?
Thanks Thanks, mate. Great presentation, thank you. You mentioned at the top the paper cut problem. I was wondering, is there any resources that, us kind of managers and leaders in the industry can look at where we can, understand that more fully and try and help and alleviate those kind of little, paper cut type issues and make a better environment?
Yeah, so I didn't go into detail because, frankly, there's quite a bit. If you go to girlgeekacademy.com, there's actually, it talks about the pipeline problem there. There's actually quite a bit of resources there and also hyperlinks. We try to keep it simple. We don't go into too much, we've got to make it practical and something that we can actually change and create something useful from it. So we're trying to change things, make things better by doing, right? I mean, it's always been my rule. It's like you got to do. It's enough to talk about it, but you got to just do it. And that's in everything. It's in coding. It's in learning. It's in changing people's perceptions. You got to just do something.
I just also want to share some personal experience. So I went to uni a few years ago, back in the day, and I actually studied computer science. That's how I actually ended up being in this industry. When I first started, I think it was during orientation week, first year, I think there are more than 10 female students. I don't know exactly the numbers, but there are significant numbers of them. But fast forward a few years later, when I graduated and I went to the graduation ceremony, there were actually less than 5 female students graduating, including me. I knew personally some of the students who have dropped out or even pivot to another degree. Yes, definitely there's an issues with this pipeline. Also another personal story, I knew an old friend from uni. She was a software engineer like me, not a mobile devs, and she was working in this big ASX listed company. But she had some traumatic experience in that company. She, without going too much details, but she was experiencing some bullying, toxic environment, and and she actually went to sue the company and won. But from that experience, she decided to leave tech industry completely, and nowadays she's not in IT or even becoming an engineer. So yeah, even post graduations, that problem still persists.
We all got stories, so I'm going into it. But I think, again, back to we do little things. We make little steps towards making things better. And that's kind of all we're trying to do here. Ultimately, we can't do it alone. We need everyone else to help.
Sorry. I just want to add, even if you're not women, you can also be an ally. Be supportive. Highlight your female engineers and give them opportunity, give them space.
Sure.
Oh.
Yeah. Awesome. Thank you.
We've got one more question.
Okay.
Oh, 2 more questions.
Thank you. I was wondering, do you have any workshops for other languages like Kotlin, Android, JS, TS, web development? Just curious.
Not right now. But it's so we've got to be mainstream, right? And particularly when we have made it a conscious decision to focus on the pipeline. So we haven't run an adult SheHacks for a little while. I can't remember exactly the last one we did. We did run the SheHacks games, which was similar, but it was really around gaming industry and coding for gaming. And that was aimed at sort of adults. Well, adults who like to game, I guess. So it's we were limited capacity because it's all volunteer run. So yeah, I mean, if you've got a good idea, get in contact, and we'd love to try and help. But not everything's going to be able to, unless we have a groundswell of interest, it's hard to kind of bring something like that across the line.
So, okay, yeah. If you're interested to volunteer, don't forget, save this email address and contact us.
Thank you very much.
Sorry. Is there
One
another?
more.
Oh, sorry, one more question.
I'm sorry.
All right. So I have 3 daughters, and unfortunately, only the youngest has shown any interest in software development. But I taught her a few different languages, but she learns the basics, and then she kind of loses interest. So I'm trying to find something that an application that she can do with the programming that'll kind of inspire her. But she's very artistic, but I haven't had a lot of a lot of luck getting interested in graphics or animation, because she just prefers to use a pencil.
No, I understand that. So, I mean, ultimately, some people are just not interested, and there's nothing you can do about that. But I would maybe, and this is going to be maybe contentious, if she's someone who likes to make things, because I think ultimately as engineers, we like to make things, right? You like to go, I did that. I fixed that exchange back in 1992, and it now works, until they replaced it, 2 years later. It's that act of, creating something that didn't exist before, that you did, particularly if it's something brand new. So maybe, and some of the AI coding things are actually pretty good.
Yeah.
Right, and some of them, if you can control it, which is, I guess, the next thing, allowing them to make stuff and just use it at a very kind of, prompting and context and everything else. And if they enjoy doing that, that could be the gateway into engineering.
Yeah.
I don't know. It's just a suggestion. It's just something that popped in my head.
She likes the block-based stuff, like with Scratch,
Okay.
So I teach her something more sophisticated, and 2 weeks later she's back with the block stuff.
The box stuff is kind of cool. It also works with Lego Mindstorms. But, yeah. I don't know. I mean, ultimately, how old are they?
So the youngest is 11,
Okay.
and I've got a 16-year-old and a 19-year-old as well. So the 11-year-old is the only one who's expressed much of an interest at all.
Yeah, you're a big IT person, and you do lots. Have you got the house all IoT'd?
Not quite, but
you're like big Uber nerd at home. Maybe she's rebelling. Maybe she's going to take pottery up.
yeah, yeah.
It could happen. I did that to my parents.
Yes.
So I didn't do pottery, but
I do know that if she decided to do it, I'd be seeing a lot more progress.
Yeah.
It's because I'm suggesting.
Yeah, as an engineer, I'm the least qualified person here to give you advice on raising your child. I don't know. I honestly don't know. I think I would try something myself, like using some of those AI tools, because they are really a lot of fun.
Yeah.
Yeah. Even CIOs can use it. So.
Thank you.
Thanks to April and Nabila for that inspiring talk. I'm just going to have a bit of a chat about the audio product I'm working on that has a lot of Swift in it. I don't have it to show you because it's not finished, and it's also maybe a bit boring because it doesn't really make any sound of its own accord. It's very much a kind of utilitarian thing I wanted to build to use in my own studio. I mean, I'm hoping there's some interesting bits to talk about. And if not, you can tell me to hurry up. Anyway, I don't want to talk too much about myself, but I'm mostly working as a musician now. I kind of worked in IT for a long time and then decided to get back to music maybe about 15 years ago, so that's kind of my day job. But yeah, I kind of got bitten by a technology bug again recently trying to work on this audio product, and I thought maybe it might marry a couple of two things that I'm interested in. A long time ago, I used to work with a lot of neck stuff. I don't know if you guys know Sean Woodhouse. I think he's a person about town. Anyway, Sean and I worked together in 1995, 96 for a company in Australia that did a lot of next step stuff, and which was pretty unusual. And then when Apple bought Next, I ended up doing some stuff, bits and pieces of macOS. But that's all very old and probably doesn't exist in macOS anymore. But I've been enjoying playing with Swift, particularly since it was open sourced. Anyway, I'm just building this thing, and I've got like I've got a version of this is not the final thing. In fact, this one doesn't even work because it had some errors on it. But basically the idea is, and I don't know how, I presume this is more IT than an audio audience, so I don't want to go too much into the boring details about what the requirements are and how it works. But generally, as a musician, you're on stage or you're in a recording studio, and one of the really important things is to be able to hear yourself. In the old days, when you had a bunch of people just playing around a single microphone, that was pretty easy because no one was wearing headphones and everyone just balanced themselves acoustically, and that's probably how some of the greatest music was ever made. For one reason or another, that's not how things are done now, and people tend to wear headphones, and one of the important things is you have a great mix in your headphones so that not only can you hear yourself, but you can hear the other musicians with whom you're playing in a nice and balanced way. And it can be nice to have some control and autonomy over that yourself, because the cognitive load of yelling at the engineer to turn you up, usually it's you want to turn yourself up, when they might be trying to do a bunch of other things, is often not an ideal workflow. And most people are used to dealing with smartphones now. It's not too hard to turn something up or down. So the idea of this product, and it's certainly not a unique idea, I think maybe I just have doing it in a slightly nicer way, is to build something where the musician will have control over their mix themselves. It'll be low latency so the time between when they strike the note and it gets captured and you hear it back in your ears is really low, and that's important for people's performance, particularly if you're playing a percussive instrument. Really, ideally, you want it to be under a millisecond from the time the sound hits the microphone to the time you hear it in your ears. And with a whole lot of things like a network and digital analog conversion stuff in the way, that latency budget gets eaten up pretty quickly. And yeah, another thing is that the audio is delivered over network, so that's kind of nice. You can mix both audio and control information together. You don't have to buy expensive things to distribute the audio. You just go to Officeworks and buy a network switch. Basically transfers some of the commodification of the IT industry, which is a big industry, into the audio industry, which relatively is a smaller industry, and lets you take advantage of some of those things. Been working on it for almost 3 years now, and I didn't think it was going to take this long, but it has. And it's a bit depressing because I haven't done as much music in the last couple of years. I also have a young son, so that's my excuse, but my real reason is I've been spending a bit too much time on this. Anyway, this is kind of how it started, with a bunch of messy boards. I should say I'm not really a hardware person. I don't really know anything about electricity. can understand to the extent that it mirrors logic. I can understand it, but the closer it gets to actual electrons moving, I have very little idea. A high school physics student would know more than me. So I've made lots of silly mistakes, but I've had met lots of lovely people who've helped me out, and that's been really fantastic. So I just started off with a bunch of development boards, and you can see that user interface there looks pretty terrible. I think I showed it to Sean or one of my friends, and like, that's not actually the UI you're going to ship, is it? I thought it looked pretty good, but you know, it's nice and minimalist. But and yeah, the actual thing, I mean, I'll explain a bit more in a second, but yeah, it's just running in a Raspberry Pi. Again, there's nothing. This board itself is a custom board, which has all the audio stuff on it, but a Raspberry Pi compute module just slots in there. And the reason for that is that if you want to design your own, if you want to design that stuff actually into your board, and you have really high-speed things like RAM and stuff and Ethernet. Well, there is Ethernet on this board, but it gets complicated real fast and expensive, and you're going to make a small number of things. You're not going to save any money by doing that. The Raspberry Pi compute module is perfect for this kind of use case, and it runs Linux, and that's how I get to using Swift. I should also point out that there is now a dialect to Swift called Embedded Swift, which strips out like a bunch of the runtime stuff to make it more easy to use on bare metal devices. That's not what I'm using. I basically need too many of the features that have been left out for that to be the case. And I've got an operating system, so you can just use Swift, the normal Swift. That was an early 3D printed prototype that I took to a trade fair last year, which, you know, it didn't work too well, but it kind of worked. It did unfortunately overheat in there, and I was wondering why like the CPU usage was going through the roof, and as soon as I took the case apart, because it only occurred since we put it in the case, which of course was done like the day before the show. Anyway, we will fix, I mean, obviously nylon is not very thermally conductive, something we'll fix. But you know, it's just so many little things. Like, you want to have a display that's a bit nicer than the one you get with a Raspberry Pi, well then you're going to go to Alibaba and find, you know, get a bunch of quotes for some really high-res displays like you might find on a smartphone. That's great, but you're going to have to write your own kernel driver. All that stuff. None of it's like impossible. It's just, there's just a long list of things, and each of these things takes time, you know, sometimes a month, sometimes a couple of weeks. And all this time adds up, and that's how I still haven't finished. But on the right's kind of what it will look like. I don't think it's going to be pink, but it will look something like that. And effectively, this board is just going to be shrunk down a bit, so it's thermally a bit better, and so we can make the unit a little bit smaller. But you can see things like these connectors. That's where the Ethernet's supposed to be, but these things have quite a high internal profile, long internal profile, so you can't actually make it. If you're going to have plugs, you can't make it look like a smartphone with an edge-to-edge screen, because there's no, unless you're going to make it really tall, there's just no room for the things that have to fit inside it. The architecture, again, you know, it's probably a bit boring if you're not into audio protocols, but I'll just quickly draw the distinction that everything's remote controllable, so the user interface itself is just a client of this control plane, which is really nice, because then you can, if you've got a bunch of devices, you can automate or you can control them from somewhere else in the network. It means if you want to save, like recall and save people's settings, then that's easy to do. The device has got a couple of different independent headphone outputs, which you can see here, and you know, your buddy, she might have like a smartphone, control her mix from that, and you control yours from the touchscreen. And it's exactly the same, using exactly the same protocol. It's just that one UI is running over a domain socket and the other one is running over TCP. Also, I'll get to the UI stuff in a bit, but I made some choices to try and be able to reuse as much of that as possible. And then internally, there's a daemon that accepts these control commands, and then it kind of fans those out to lots of internal protocols that just connect, that happen over like serial ports or SPI or I2C or whatever. That's just happening within the board. So that's not, that's kind of opaque to both to the UI and to any remote clients. Why did I choose Swift? Well, I guess because of I do actually wonder now whether it was the right choice, but you know, I'm pretty too far gone for that now. I think I have a bit of emotional attachment to Apple's technologies because of working with Next Step 30 years ago and kind of following Apple from when it was running Objective-C and stuff from when it wasn't so cool. So when Swift was open source, you know, I wrote a few apps and stuff and I just had a bit of fun. So of all of the kind of successor languages to C, it's probably the one I'm most familiar with. I don't really know anything about Rust, and my C++ isn't very good. Kind of like the fact you could develop on macOS, because it's kind of, in spite of what people say about Xcode, it's still a fair bit friendlier than developing just with, you know, from the command line. Its Linux support's pretty good. It's definitely been getting better over the last few years. The things I don't like about it, I mean, I do like the async await stuff, and I've used that pretty heavily, but it's hard to debug. On the other hand, it's not really a criticism of Swift because any concurrent programming is hard to debug. You're just kind of shifting around where the pain points are. The binary sizes are pretty large. That's even when you build in release mode and strip everything, it's kind of a bit on the annoying side, particularly if you're on a constrained platform. It doesn't really matter with a Raspberry Pi because relatively the smallest ones still have got oodles of RAM and flash, but if you want to, there's some other product ideas where I would want to maybe use a 32-bit ARM and a much smaller and cheaper CPU, and Swift starts to become a bit of a problem there. Like there's one other, there's an FPGA on this board which you can load some custom firmware onto the Linux CPU that's part of it, but 4 megabytes is the most, the largest your image can be, and there's no hope of you couldn't even put Swift Hello World in that. Tooling on Linux isn't also great. Diagnosing things like memory leaks and retain cycles are hard anyway. At least on Mac, you've got some tools. The best hope is you can duplicate those bugs on macOS and use Apple's slightly better tools, and then hope the bug doesn't recur on Linux, but obviously that really depends on where the bug is. And the other thing, to point out is that the Swift stuff is really just in the control plane, like the top half of this. Anything that's happening in real time is pretty much written in C. Not only could the chips that are running that code not support Swift, I mean that would be a whole undertaking, but there's no real benefit to using a safe language. Relatively, the number of lines of code in that is small, but the amount of time spent debugging it is high, just because debugging real-time stuff is complicated and requires, you know, it's very timing sensitive, as you'd think, and it's just, I don't think the language is really the issue. It's just more, I don't know, my lack of experience or the nature of the beast. So there's no, you could use the real embedded Swift potentially on a, STM32 or something, but I didn't really need to see a reason to make things more difficult. I chose Swift for the bits where it was useful and not for the bits where it wasn't useful. There's a whole bunch of bits that I use Swift in, but I don't know, and I can give you a kind of a bit of a demo. I can't show you any audio because everything is so fragile that if I even look at it, it's going to break. So taking on the number 96 tram is not going to happen. But I can show you a little bit of a simulator. It actually may be a little bit of a good time to touch upon some of the UI decisions. So the simulator, well, running on Linux, there's just the control side of things. What happened? Oh, there we are. And that's just, obviously, it doesn't do anything. It's just running in Vegas mode where you get lots of blinking lights. But one interesting choice for the UI is I ended up using Flutter. I did a bit of a research rabbit warren into different things. There are a bunch of embedded UI frameworks that are around. They're usually written in C. They're pretty, code quality is not often that good, and they're pretty hairy. It's a bit like, it's great for resource-constrained systems, but the Raspberry Pi isn't really that resource-constrained. There are a lot of Swift UI clones, which I spent quite a bit of time looking into. It's weird that there's like 10 of them that are designed to run like either directly on a frame buffer or with GTK or on Windows or whatever, but it would be nice if people consolidated their effort and just made one really good one. Generally, the vibe I got, and again, this is 3 years ago when I started this project, things might have changed, but the vibe I got was if you take this on as a dependency, you're going to be maintaining a UI framework, and there already enough stuff to do, so I decided to avoid that. And then a friend of mine who's an electrical engineer, who also used to work with Sean, funnily enough, he suggested Flutter, which I didn't know anything about, but I'd done a bit of Swift UI, and Flutter looked pretty similar in its sort of, you know, its vibes, being declarative, it seems kind of similar. So yes, if this very early UI that I did, that's kind of around here, was built in Flutter, and then I paid someone that knows how to write. I paid a friend to design something that looked good, and then I someone else to implement it. So basically, there is something interesting though, which I'll tell you a bit about. I'm not going in order here, but one thing I wanted to do is keep all the business logic in Swift. So I wrote, and Flutter has this abstraction which it calls platform channels. Basically, you're just shoving some bytes between the managed Dart world of Flutter and then your native code world. You get an implementation of that on macOS or iOS from the Flutter framework, but I didn't have that on embedded Linux, where we're writing directly to the frame buffer. Well, it uses OpenGL, but you know, you take over the whole screen, you don't have all that stuff. So I wrote for this thing called Flutter Swift, which is basically a pure Swift implementation. These platform channels. Uses Codable, something I kind of regret using because Codable's super slow, but it also ties Flutter's event loop in with native Core Foundation run loop, or on Android, which I'll get to in a sec, with Android native runtime. And there's a fair bit more stuff on Linux. So that's one of the big things. OCA is a control protocol. There's a bunch of other things which I'll touch upon in a bit. And I today updated my stats. Not entirely accurate, but Swift is the majority of code, and by code I mean something that I or someone I've contracted has written specifically for this project, not dependencies. Over the last year, actual lines of code increased by about 35%, but Swift remained constant at around 3/4 of the code in it. So it's only the real kind of very platform specific or real-time stuff. That's in C. And then the UI's increased a bit in percentage terms because it's just got more featureful over the last year. I don't know if I'll bore you about OCA. OCA is just a way of controlling things. It's an audio industry protocol, just an RPC, you know, basically says I pushed a button, and then things that subscribe to that can say, oh, a button was pushed. Well, I'll change my UI. So it's both a thing for signaling, invoking things, and also for getting events. Supported. It's an open standard, so it's supported by a lot of different vendors, and you can build clients that will discover the capabilities of the device and show them a user interface. It was kind of nice. So we use it for everything, and it gives you, kind of a tree view of everything if you want, but you can build your own UI, obviously, and that's what we've done. I touched a bit on Flutter Swift before. One thing I did go on a bit of a rabbit warren, which I just haven't had the time to keep up to date, is porting Flutter Swift to Android. And I was involved with porting the Swift Java, which is Apple's kind of Java native interface bridge for Swift, porting that to Android, which wasn't that hard. It's and more capable people than I are doing it now. But I wanted this app to be able to work cross-platform because, ideally people would be able to, musicians would be able to use a smartphone or a tablet to control the device, as well as touchscreen the device itself. And in this somewhat dated screenshot, which you can see some buttons labelled stress test, which won't be in the final product. But you can see that I'm running in macOS, starting from the bottom right and going counterclockwise in macOS. In the iOS simulator, there is, it's running in VMware under Wayland on Linux in the top left, and then in the bottom left, it's running in the Android simulator, and all of that native, all of the business logic code on Android is running in Swift. I wrote a bunch of extensions to integrate Swift, to write a custom executor so you can schedule async tasks on the native Android run loop. integration with Android logging, a whole lot of nice to haves that made it more of a seamless experience. And then the UI is still running in Flutter, but which obviously is natively supported in Android. A little bit of Java code to glue the two things together. That's something I haven't had time to maintain, but as hopefully you get closer to shipping a product, we'll return to. And a few more nerdy bits to finish. Again, it's a bit of a random technical deep dive, but I just tried to pick out the bits that were written in Swift. Linux has a kind of interesting I/O subsystem in the kernel called IOU ring. Unlike things like select, basically, instead of telling you when your read or your write is your socket's ready so that you can do a read or a write on it, it basically does all the I/O for you, and it says, "Hey, you're done," and then it gives you a buffer with the completed I/O if you're reading something. That seemed kind of nice. Actually, I originally used it because Linux has no user space asynchronous support for SPI, which is one of the serial protocols we use. But you could do it with IOU ring, because one of the nice things is that if the underlying operation or device doesn't have non-blocking support, then the kernel will spin up a thread, do the I/O for you synchronously, and then still notify you asynchronously when it's done. So that seemed like a nice. There's a guy in a Swift forum that suggested this, but it seemed like a very nice match. This async I/O API matched very nice to async await. So it kind of took me a while to get my head around, but basically we have a little wrapper, which is an async await interface to IOU ring, and effectively when the operation completes, the kernel notifies user space, kind of goes through libdispatch because it needs to monitor a file descriptor, and then registered as basically a pointer in the IOU ring user data is a block, and that block then spawns a Swift task, which either resumes a continuation if it's a one-off operation, or sends data on channel if it's a multi-shot thing, like accepting new clients on a socket. So that all worked pretty nicely, and one of the nice things, you can also coalesce notifications. So if you've got a bunch of things, you can reduce the number of system calls. The general vibe with IOU ring is reduce number of transitions between user and kernel space. We've also got a nice little async I/O wrapper for things like Ranger UARTs and SPI and I2C and GPIOs and all that sort of stuff. So there's, as you probably know with Swift, if you're using structured concurrency, everything has to make forward progress. So whilst it is kind of acceptable to take a lock briefly, or it's probably fine to write to on a serial port to something that's local on your board, but ideally you don't want to do anything that could block. So in order to do that, you need to somehow use some asynchronous I/O. The other thing I've been working on, which was originally started by another person, but I've kind of taken over maintaining, is support for Swift in Yocto. Yocto is super popular and embedded hardware that uses Linux. It's basically like, it's this horrible mess of shell script and Python, but it's like a construction kit for building a custom embedded Linux distro. So instead of maybe starting with something like Debian and just stripping out the bits you don't need, Yocto, you kind of start with nothing, and then you just add in the bits you do need, and you basically have like a build world command, which will build everything from scratch and spit you out an image that you can flash onto your device at the end. So one thing is to add support for Swift to that, so that you can take a Swift PM package and with just a few lines, turn that into a Yocto package. So that's something I have ended up maintaining, but it's really a critical part of, because there's so many dependencies, so many packages, it's not possible you really need to be able to build everything from scratch. And there's a bunch of other things I've done. Many of them aren't that interesting, but just integration points with things like systemd on Linux, or we were using for a while Adafruit's seesaw thing for encoders. Now we're using something else, and then integration with Androids, Looper, which I mentioned before. Just lots of random things. Basically, if there was an open source, I've kept the interesting things that are specific to this hardware proprietary, because I would like to, sell the product and make a few, but eventually anything that's open source, everything else, the infrastructure stuff I've open sourced mostly because I'm like, well, if I don't finish this, I want to at least leave some breadcrumbs around that might be useful to someone else. So yeah, that's the sort of random walkthrough, product. I'll go back to the pretty picture.
Nice, I pinched the microphone first. Firstly, I will never misuse the term yak shaving for my own work ever again. What you have gone through is just incredible. When are you coming back for part 2?
Ha ha ha. Well, I mean, that's one reason, because I'd hoped to do this talk ages ago, but I was like, let me wait until I've got something, in a box, and, it's like, I'm hoping to have something. I like to have some things in boxes by the middle of the year, but if you think software schedules are hard to estimate, I mean, hardware adds another, it's hard, there are tools to debug it, but it's particularly as a non-hardware person, there's just a lot of staring at things. Like, for example, bringing this new display up, just doesn't work until you get the things, magic incantations right, and it does work. It's pretty hard to estimate how long it's going to take when it's 0 or 1. Doesn't work or does work, whereas software generally tends to hold your hand a bit. But I'm hoping that doesn't answer your question. By the middle of the year, I'd like to at least have a few that I can, get my friends to use.
I'm really curious. You mentioned embedded Swift earlier. I'm not super familiar with it. So what does that cut out compared to regular Swift? And what did you find that you needed? And you mentioned, would you write it in Swift now?
Yeah.
Several years later, would you? And if not, what would you use instead?
Yeah, great questions. Embedded Swift, it does cut out a lot of stuff to do with protocols and generics, which I've used pretty liberally, I think, to minimize the amount of runtime metadata that's in the binary. So that's one thing. I think at the start, the limitations were pretty severe. I don't even know if there was a string type. I think it's really for stuff like you've got a microcontroller and you want to make some LEDs blink. I mean, obviously that's a contrived example, but that kind of stuff where you're just writing to registers, or maybe it's something you would use inside the kernel, or Apple might use inside the secure enclave or something. And I think they're adding non-embedded features into it bit by bit. But when I looked a few days ago at the list of things that weren't there, they were still pretty significant if you're used to writing Swift, with liberal use. Oh, no async await either. I think that'll come. But I mean, all the things that I use, protocols like type erasure and async await, I mean, I'd have to rewrite everything. And well, at that point, you'd have to get to your next question is, what other languages might I've used? I mean, I think it's too complicated to write something like that maintainably in C. Modern C++ is probably a good option, but I'm not familiar with it. I guess I probably would have gone with the cool kids and learnt Rust. I'm not convinced that was a great idea. It would have been a great idea though, because Swift, because of its philosophy of progressive disclosure and some of the decisions it makes about memory management, do make it a lot easier to start just writing code without having to think about things. Whereas my understanding of Rust is you really have to think about things. It sounds like it would take some of the fun out. Having said that, I have been using Claude to translate one of the components from Swift to Rust as a bit of an experiment to see if I can, firstly as an experiment only not actually looking at the code because I don't understand Rust, but also can I just verify that it works from the tests passing. The real goal is to see whether I can get the binary size down, because that's the biggest problem with Swift. Some of these binaries, and if that's the only thing on your Swift, on your embedded system, you have to include the runtime cost in it because you can't amortize it against across multiple other things. So these binaries that are statically linked, it's 40 or 50 meg. If that was written in C, it would probably be I don't know, 2 meg or something. And yeah, I'm careful not to use Foundation, so that strips out a bunch of stuff, but it's still pretty easy to pull things in. And I think you have to be pretty aggressive to try and, like, you have to do fancy linker, wizardry to try and get it down. And like I could get this thing down to maybe 11 meg if I compiled in release mode and stripped the binaries, but this is one of the smaller components of the system, and it's still too big for some use cases. But so yeah, Rust would probably be the obvious one, but I don't think it would have been as much fun. The biggest problem with Swift in the embedded world too is that people do think you're a bit nuts, and a lot of the open source stuff I've built that I would hope other people would use, no one wants to touch, because in that community, no one knows Swift. So that's a little bit sad, because I've open sourced stuff that even doesn't need, even if you want to use it, it's weird. I feel like this doesn't exist with Go, whereas, like if a program only exists in Go, I remember downloading something, I don't know anything about Go, but I can at least follow the instructions. I feel like Swift still has a bit of a smell about it, particularly on non-Apple platforms, that it's, I don't know, it's just not going to work or something, or it's not going to be maintained, or it doesn't work on Linux. I mean, it works great on Linux, apart from the aforementioned issues. So that's a bit of a, whereas people love Rust because doesn't have that perceived tie to Apple, and Microsoft's using it, and yada yada. So I don't know.
I think another question at the front.
Hey.
Yo, so really good talk. Got a lot out of it. It seemed to be, here's all of this stuff on hard mode.
Yeah.
Whereas for me particularly, it's been a long time since I've touched Linux embedded stuff. Is there an easy approach to getting started?
Great question, because my friend Max, who's designed the hardware, tells me not infrequently that I'm doing this on hard mode, and he's like a hardware designer. And in particular, ironically, choosing things like Swift to him is doing it on hard mode because it's an unusual choice. Makes things harder. Ironically, for someone that's not familiar with hardware, some of the embedded Swift stuff, or there's a thing called Swift.io, you can just buy a little box and you can make some lights blink and stuff and write in Swift, actually provides a pretty nice entry point into hardware. But I guess the classic example, and maybe Paul, you'd have a better knowledge than me, because I did kind of dive into this because I wanted to build something and I didn't care how hard it was going to be. I guess Arduino is probably the classic example of getting into something, without too much, with a sort of, in an easier way. And I did some of that stuff a while ago. I was very fortunate to have someone to help on the hardware side. But yeah, if you wanted to build something like this in easy mode, you could probably build something similar that just ran purely on a Mac or Linux or whatever. The problem is the latency would be it would be several milliseconds, which is not going to be much fun to play music with. So it does, for this particular application, I think it needs hardware support. But for general tinkering, I think it's never been a better time to experiment with hardware, and I think I probably would have benefited from trying to do that first instead of diving into hard mode. But the flip side of that is this board can be made in China for 2 weeks, and sure, it's going to cost you a few $100, and you have to make at least 2. But compared to like 20 years ago, I mean, if it doesn't work out, which this one didn't because there was a mistake on it, well, you just do it again. So it's becoming, the iteration's becoming closer to software. It still costs more money, but it's not like tens of thousands of dollars. So I don't know, I hope that vaguely answered your question.
So just, that's actually a very similar question.
Yeah.
So if this was a Chinese product,
yes,
it wouldn't have a screen.
Yeah.
You'd be doing it from your phone.
Yes.
And it would be a web page.
Yes. That's a very popular approach actually in this in this world.
Would that have been easier?
I mean, for me, no, because I don't know any. I've got a big blind spot when it comes to anything web related. The last time was like 1995, writing a web page in Notepad. Most people are doing similar stuff. There's like a lot of mixers, not for this use case, but a lot of mixers. In fact, the guy that kind of pioneered this is from Melbourne, but the box is just a black box that you snap your iPad into, and the UI runs on the web as a web. So yeah, that would be. For me, web is a bit of anathema to me. I don't really like webby things, but And also that would have only solved the UI part. It wouldn't have solved all of the other parts.
Yeah.
I mean, again, using Swift, yeah, maybe you wouldn't need to use Swift, but at the end of the day, you're going to have something that is mixing the audio. That's definitely not going to be done in JavaScript or Swift. It's more likely to be done in embedded Swift at some point.
And that's what you need to run on the device itself.
Yeah, exactly.
For
Yeah.
the
So
latency.
and that's still, like, the UI was a chunk of work. Although, I don't know, I mean, Flutter versus web, I think it's probably, if you're familiar with it, it's probably about the same amount of work. You're still going to need something to glue that to the actual hardware.
Yeah.
And then you're still going to need the hardware. So doing it on hard mode, it did make it harder, but you still need to solve these problems, most of these problems somehow. And part of having the touchscreen in the device is I want to choose a touchscreen. I want something like shitty Android tablet. I want like really nice, bright, 300 ppi display. That's like I'm building something ostensibly for myself and my friends. That's a premium. There's no way I can make it cheaply because I'm only going to make a few. So you may as well make the most booty thing you can. And that's kind of been my goal for the whole thing, because there's no way you can compete with a cheap Chinese product. Because if you couldn't compete with a cheap American product, because it'll be made in much larger volumes.
Yeah, yeah. No, it's a fair response. It was just something that kind of entered my mind.
But yeah, the web UI is super popular. Yeah.
Yeah, and I guess this will make it really hard to clone. So no one's going to try and clone
maybe
it.
like I don't know. It's like you'd probably be stupid to clone it, I guess. But I guess
so
there's always
you're safe sending it to PCBWay. It's not.
Yeah. I mean, I just sort of think about that a little bit. I mean, but of course the magic's in the software. As long as they never see the software, it's not that big a deal. I have thought a little bit about how much do I want to lock down the Linux image, because I sort of want people to be able to tinker as well.
Yeah.
But you obviously don't want to. I spent a lot of, even irrespective of the money, I spent a lot of time on it. I'd like to get my investment back.
Just a general question, like, have you ever heard of the Connected Community Hackerspace in Hawthorne? Because there's a lot of engineers there, hardware engineers. Like Andy Gleam, who's the guy who...
Oh, I know Andy from Java. Andy Gelme, is it?
Or Gleam.
I don't know. Yeah, I know him from like 30 years ago.
So he actually created LifeX.
Yes.
And
for a long time.
his advice was to keep that separate, to keep the difference with LifeX was that the firmware was kept here.
Yeah.
So while that was manufactured in China, you didn't have that issue. But just be curious, there's a lot of people there in that group that he knows that could help you. I don't know.
I've been really lucky through to meet some people, both here and overseas, who know. Like Paul is sitting here, and I've met some. I'm not saying I don't need to meet more people, but I've met some people that, particularly with experience in the audio industry, that have been super helpful. And actually, there are some in Melbourne. I mean, obviously, no one is manufacturing stuff here, or I imagine really assembling
there are
stuff.
a couple.
But there's some great audio companies like Melbourne Instruments. There's Freakport. There's Turtle AV. There's I've just discovered this stuff in the last 6 months. There's a burgeoning audio hardware industry here, and everyone has been really helpful. And I mean, I don't know shit from clay really. I'm just learning as I go.
Amazing.
So I'm really impressed how encouraging people are. I think maybe it's because I've had a music career. Maybe it's more interesting or something.
Last question.
Yep.
Two questions? Last question. Are you sharing, writing this down, blogging it, any of this process? I probably won't buy the device, but I'd buy the coffee table book.
It's sort of been on my it's sort of been on my list. Maybe I should. Yeah. Do people read blogs still?
100%.
Okay.
Like, if you wrote any of this, it would definitely be eaten up. Like,
I like writing, so yeah. I should.
You had at least 17 sub-talks in those slides.
Yeah.
Like, it was amazing.
We'd watch a video of you just soldering things.
Oh yeah, I don't. Well, it would be a very short video because I'm a terrible solderer. Only in emergencies.
Yeah, just a simple. If you would like to update the embedded Swift, does it offer over-the-air
Yes.
software update?
Yeah. So particularly as someone who might not ship a completely finished product, being able to update stuff is super important. I'm using a thing called Mender, which isn't written in Swift. Actually, ironically, it was written in Go, and they switched to C++ because I think it was just easier to target embedded platforms with. So yeah, over-the-air updates will be supported, and there's a whole lot of Swift integration around that, which I've open sourced. But the short answer is not Swift specific. Every device has an A and a B partition, and you basically blow away the whole, blow away the user's data, but you blow away the read-only whole operating system image when you do an update. It flips a bit in the bootloader that says, hey, load from the B partition if you booted from A, or vice versa. When you successfully boot, then you set a bit saying, okay, I'm going to continue booting from this one, and if it fails, then it just boots from the old one. So that's pretty common, and there's a great open source thing called Mender for doing over-the-air updates, and obviously their business model is sell you a subscription for all of your devices in the field, but that requires that they're connected to the internet, and in the audio world, often devices are not connected to the internet, so firmware updates are going to be done by downloading something from a web page, and I have to write an app, which I haven't written yet, that will flash the device.
Well, thank you, Luke.
Thanks.
That's awesome.
Cheers.
Awesome. All right. Thank you very much for everyone for coming, and our speakers. Another round of applause. Have I forgotten something? Okay, just another reminder. We've got coding night on Wednesday. The social night on I'm not sure if that's the date 100%, by the way. 31st of March? It is? Last Tuesday of the month. Yeah. Good. Okay. And thanks again to our sponsors, Mantle Group and REA Group. Good work. And then, yeah, we'll finish off at the social time at the tavern. That's it. I've forgotten something.